I want to show you a little bit on how to use this PhET simulation kind of virtual lab for circuits. Some of these things will be familiar, some of them we'll learn a little bit more later, but the basic premise here is that you've got a set of tools over on the left where you can, or items that you can use to build circuits. The basic ones on the first kind of set is really what you want to start with. Wire, battery, light bulb is where we'll start today, but there's also other things like fuses and other batteries that kind of behave in different ways that you can change and so on. But we'll get to all of those. There's light bulbs and resistors and dollar bills and other fun things. So we will play around with all of those a little bit. There's also the ability to turn a few things on and off. And so I'm going to start by building a basic circuit, right? We need a battery and we need a conducting path. So we need a voltage source, we need a conducting path. And it's not required that you build them like this, but I think just for visually to make it simple, I'm going to try to build everything with nice kind of square corners for today. And one more wire. And the reality is there's really only kind of one wire here, or maybe two, but I'm just using them to build it this way. And when you connect it, you see that everything works. Now this leads us to talking about the current flow. This is showing what the electrons are doing. Notice they're going into the positive terminal of the battery and out of the negative terminal of the battery. You've also noticed that as I click on the battery, this is an ability to switch the direction of the battery if I want, or change the voltage of the battery. You can either do the slider there, or you can click on these to go by 1/10 of a volt, if you want. So I think it was at 9 to begin with. You can also click on everything else. You can change the resistance of the light bulb, the wires themselves, nothing. If you click on them, they let you delete them. If you click on the corner, you can cut the circuit apart and then put it back together. So this is electron flow, but you can turn off the current. You don't actually have to see the current. This is what it would look like if you were building this in real life. You wouldn't see the current flow, right? And you can turn the current on and do electron flow, but then there's conventional current. And this is what we describe as current, that it goes out of the positive into the negative, which is not what actually moves. That's Ben Franklin's fault, as you'll hear me say many times in this unit, because he didn't know about the fact that electrons could move easily and protons were stuck in the nucleus. We had no way of knowing back then. Those experiments hadn't been done, and at the time that electricity experimentation was happening, this is kind of what got defined. You can also just turn off the current, which is what I'm going to do for now. And you can, if you go over here below the pictures of the items, you can switch between kind of real life representations and what's known as schematic mode. Now, the one here that is kind of different, normally we just draw a circle for a light bulb. You'll see that on pieces of paper, but this is the light bulb shown as a schematic. And then this is the battery, a long and a short, the long being the positive side, the short being the negative. You can see that as I flip them. Okay. So this is the circuit working just fine as a schematic. It doesn't give you any visual clues that it's working. So that's why sometimes this is a nice one, and showing the current, conventional current flow can be helpful. You can also show some values that will tell you the resistance and the voltage of various elements as kind of they are. The other thing you can do, and I'm going to switch back to schematic mode and turn off the current, but just imagining that we're building this in kind of real life. We have what's known as a voltmeter and an ammeter or current meter. A voltmeter measures voltage in volts. A current meter or an ammeter measures current in amperes. Those are our units. Now, the voltmeter is the easy one to use. You simply take the probes and you touch them across the thing you want to know the voltage. So across the battery, 9 volts. If you remember, this was a 9-volt battery, right? If you touch them to the same spot, it will read 0 voltage, because this is an energy difference at points in the circuit. And that's true everywhere in the wires. There's not going to be any voltage difference. But then if you go to the light bulb, you will see a voltage drop of 9 volts. An interesting thing is if I swap these probes, you will get the opposite, negative. Normally, we're just interested in the magnitude of the voltage, how many volts, how much energy per coulomb of charge is dropped across that. So that's how the voltmeter works. You can put that away. The current meter is different. Current is measured as a flow of electrons through something, or a flow of charge. So in order to use a current meter, we actually need to break our circuit. And so I'm going to put this current meter right here and wire it into my circuit. And now it will measure the current flowing through it. And if I go back to the representative model here, and we kind of turn the current back on, right, this is what's happening, right? If I take the current meter out and reconnect this circuit, that still happens, but I just am not measuring the current. So when we're doing a current meter, you always have to break the circuit apart, wire it in as if it were a wire in the part of the circuit you want to measure the current. Okay, so that's how this sort of system works. You can do all sorts of other useful things, right? You can just delete that. We can make other branches in this circuit. We could put in, another light bulb here, 2 light bulbs going together in series. We could break this apart and make a parallel circuit like that. But that one's a mess. You probably don't want to ever draw anything like this. You usually want to draw them like this so you can see them. But you get the idea, right? So you can do all this. And if you ever want to clear it all, you just hit the reset button and everything will go away. Okay. There's some advanced stuff over here, and we'll get to that later, where you can change the battery's resistance and the wire's resistance, and put in a real bulb that behaves in a little more complex way. But that is the basic setup of the circuit construction kit.